Welcome back to Aurora Tech Channel. Today, I will be reviewing the Genmitsu 4030 PROVerXL V2 CNC machine. This desktop CNC router has a working area of 400 by 300 millimeters with a Z height of 110 millimeters. Instead of the lead screws and stepper motors you normally see on hobbyist CNC machines, it uses 1204 ball screws to minimize backlash, along with Nema's 2376mm high-torque closed-loop stepper motors that provide feedback to the controller board to prevent skipping steps. For the motion system, it uses double-side palm wheels on the X and Y axes, and 12mm steel rods on the Z axis. Thicker aluminum extrusions have been used to construct a more rigid frame. The spindle is a 400-watt air-cooled type, and the Z axis is fairly rigid, making it well-suited to holding this larger 400-watt spindle. This CNC machine also uses higher quality limit switches on all axes. The bed is a hybrid MDF T-slot design, offering convenient mounting and easy replacement if it's damaged. It comes with a well-organized cable chain that neatly houses all cables for better cable management. The spindle is powered by the DC power supply, and its speed control is managed using a knob, similar to a DIY spindle upgrade. All components are packed inside a controller box containing the motherboard, power supply, and an emergency switch. Considering its price of around $1,300, the hardware specs of this machine are pretty solid. I will test it with various materials including softwood, hardwood, acrylic, and aluminum. Based on feedback from some viewers, I will be recording the machine's sounds during the review instead of playing my usual background music during the tests. Please let me know your thoughts on this change in the comments. I would like to thank SaneSmart for sending us this machine to review. With that, let's get started. This machine weighs over 60 pounds and it's well protected with laser cut foam. The bed and Y-axis were pre-assembled at the factory. We also have the X-axis and X-stepper motor, the Z-axis and the 400-watt spindle, a cable chain with several mounts, an electronic enclosure, a mount for the 65mm Makita or DeWalt router, as well as some tools and cables. Assembling this machine is pretty straightforward. You just need to put the X-axis on the base, attach the Z-axis to the gantry, install the X-stepper motor, and connect the coupler to the X-ball screw. Install the cable chain mounts, 2 on the gantry and 2 on the left side of the machine, and these will secure the cable chain. All of the connectors are clearly labeled, so you can easily connect them one by one. With the assembly nearly done, you should have one of each screw left. The final step is to connect the other ends of the cable chain to the electronic enclosure, which are also clearly labeled. Before turning on the machine, remember to adjust the power supply to match your local voltage. Next, we can connect the machine to the computer using the USB cable. You will notice that your device manager shows a new USB to serial port, indicating that the machine is ready to use. If this is not the case, you might need to install the driver that comes with the machine's USB drive. I will use the free Candle Gcode sender to send Gcode to the machine by selecting its COM port. After releasing the machine's emergency button, you will see the connection being established. The first thing I will do is unlock the machine and then home it. Then, I will jog all 3 axes to make sure they're working. And yes, all of them seem to be working properly. After that, I will test the spindle. Next, let's start with the sample Gcode file. I'll jog it to a starting position, let's say here, and then reset the X, Y, and Z axes to set this as the starting point. I won't install any toolbit yet. I'll just run it to ensure that everything is working. Following this, I will install one of the engraving bits that came with the machine and use the Z probe to set the tool height. With everything in place, I'll send the job to the machine again. It appears everything is working fine. We can now go to Fusion 360 and generate more Gcode files for testing. Let's start with this Stark Industries plate. I will run 2 operations starting with engraving the text and vector graphic. I will do a preview in Fusion 360 and load the Gcode file in Candle. It looks good, so let's send it. It seems running 2 passes 1 mm in depth is too much for this thin MDF, as the center of the letter D is missing. I will run it again, but only 1 pass this time. One pass does seem to be better, so I will run another contour operation to cut it out. Let's do a preview in Fusion 360. This Gcode is really simple, so I will just send it out. The result is okay, and of course, as it's just a 3mm MDF, we can pretty much get the same result even with an entry-level CNC 3018. Let's try some solid wood. I will use 1/2-inch poplar wood and engrave some text and cut a few steps like this. After mounting the 1/2-inch poplar wood, you need to set the tool height again. Unfortunately, I made a mistake and the machine went in the wrong direction and cut the clamp, damaging the bit. I had to stop it and then check the Gcode file. I forgot to set the origin to the bottom left corner, so by default it was set to the center. Let's change it back to the corner and restart the job. Okay, the text is done and it looks good, so I will change to a flat end mill. It seems using a 1mm step down at 1000 mm per minute still looks fine. Next, I will cut a Batman logo on this half-inch red oak wood at the same 1mm step down and 1000mm per minute feed rate. It almost hit the clamp, so I should have left more clearance, but it still seems fine, so I will just let it finish. As this wood is half an inch thick, I set it to run 13 passes with the 1mm step down, so it should cut through completely. This is the result without any sanding or other post-processing, and all the edges look really clean. As I cut down a bit more than the thickness of the board, you can see a cut on the MDF wasteboard underneath. Then, I will try to work on clear 3mm acrylic, starting with engraving. Next, I will change to the 1/8 inch flat end mill and run a contour to cut it out. I forgot to load the contour Gcode file, so I had to stop it and restart the job. I will use a 0.5 step down at the same 1000mm per minute feed rate to cut this 3mm acrylic in 6 passes. The result is pretty nice, except I didn't load the correct Gcode and messed it up a little bit. The edges on the acrylic are still pretty clean. Up next, I will try to work on a 6061 aluminum plate and mount it on my own mini vise. I will switch back to the engraving bit and set the tool height again. I will engrave some text first to mark the feed rate and different step downs that I will test next. Okay, I will now mill 5 slots with different step downs from 0.1mm to 0.5mm at a feed rate of 200mm per minute. I will switch to my own single flute flat end mill, which costs less than $2 but has worked pretty well with aluminum cutting on desktop CNC machines. The operation will start with a 0.1mm step down. I think the result is still pretty good at a 0.3 step down, but let's see how far I can push it. It's still alright at 0.4 millimeters. At 0.5 millimeters, the chip size looks larger and the sound is also louder, and it seems like the machine is close to its limit. When doing a 0.1 and 0.2 millimeter step down, the results are really nice. At 0.3 millimeters, it's still okay, but 0.4 and 0.5 are both a bit rough. I think something between 0.2 and 0.3 millimeters is the sweet spot for balancing speed and quality. Now, I will mill a 19 by 19 millimeter pocket using the same 200 millimeter per minute speed and a 0.25 millimeter step down. The result is nice and clean. Finally, I will make a real project with the remaining aluminum plate. I can make a small name tag starting with the facing operation, as the surface is not very clean, and as I also want to leave some cool machining marks on the surface. This is followed by engraving, then a bore operation to make a hole, and lastly running a contour to cut it out. As you can see, the plate is not exactly flat. which may be because of the vise or the machine bed, as I didn't do any trimming, so it may not be perfectly parallel with the tool head. But for a hobbyist desktop CNC, I won't put in too much effort to do that. I will just keep going down 0.1 millimeters as many times as I need. The second pass is better, only this area is still a little bit low, so running another pass should be fine. It finally took 3 passes and around 15 minutes to make it a flat surface. I will switch back to the engraving bit and do some text engraving. The 0.6mm engraving depth looks just fine. I will then switch back to the single flute end mill to run a bore operation. The hole is clean, so I will now run a contour to cut the name tag out. The total time for making this plate was about 20 minutes without counting the time required for the face operation. Depending on the flatness of the surface, it may take 1 or a few passes. If there's only one face operation, we can add 5 minutes to the overall time, so making something like this will take around 25 minutes. Including tool changing and tool height setting, it will take around 30 minutes, which is still not bad for a desktop machine. As this machine also comes with a 65mm Makita router mount, I will try a more powerful wood router to see how far I can push this machine. I will start with the same $1.50 cheap end mill to create some slots. The only difference is that I'll start with a step-down range of 0.3 to 1mm and maintain the same feed rate of 200mm per minute. At first, I encountered a mistake. The spindle went down far too much. However, despite this, the end mill didn't break, so I let the process finish before restarting the job. Throughout the test, I continuously adjusted the wood router speed, which is controlled by a knob and offers an RPM range of 10K to 30K. After the test, it became clear that the machine's rigidity is enough for aggressive usage at a 1mm step down with a feed rate of 200mm per minute. Although the edges weren't as clean as I would have wanted, I noticed that the wood router performs best when set to 2.5 out of 6 on the speed scale. Therefore, I decided to keep the speed at 2.5 and proceeded to make a few more slots ranging from 0.5 to 1mm step down. During this round of testing, the results clearly improved. Despite the stability of both the spindle and frame even during a 1mm step down, the end mill might be the only component struggling to keep up. To address this, I switched to a higher quality Speed Tiger end mill featuring zirconium nitride coating. Although I don't know anything about the details of this coating, the product description sounded promising. I ran the same Gcode to perform step downs of 0.5mm, 0.75mm, and 1mm, while keeping the wood router speed at 2.5. Using a better quality end mill certainly offered noticeable differences compared to the cheap $1.50 one. Let's talk about the pros and cons of this machine, starting with the pros. 1. The assembly is straightforward. The entire base is pre-assembled at the factory, so you only need to put the gantry on top, attach the Z-axis, and connect a few cables. It's even easier than assembling a basic 3018 CNC. 2. The build quality of this machine is solid. It includes higher quality limit switches on all axes, an emergency stop button, a 400-watt spindle, and a frame constructed from thicker aluminum extrusions. It's quite rigid for a desktop CNC machine in this price range. 3. Using 1204 ball screws on all axes can minimize the backlash seen with lead screws, and using closed-loop Nema 23 76mm high-torque stepper motors can prevent skipped steps. These factors contribute to accurate results even when cutting aluminum. The precision exceeds my expectations for a machine in this price range. As a result, I can push the step down to 0.5mm and maintain a feed rate of 200mm per minute for aluminum cuts with consistent results. 4. The Z travel is 110mm, which is pretty good for a desktop CNC. I can mount a small vise and still have quite a lot of room to work with. The Z probe is also handy. 5. The hybrid MDF T-slot aluminum bed, along with the set of clamps, function effectively. It's easy to secure various types of materials on the bed, and they stay in place. 6. There's an additional mount for upgrading to a more powerful 65mm Makita or DeWalt router. The wood router upgrade lets you push the machine even harder. I can do a 1mm step down at 200mm per minute. The cut is also quite clean with a better quality end mill, so with this setup, I can work on aluminum 2 to 3 times faster than with the stock setup. Now for the cons. 1. The Y-axis is driven by 2 high-torque Nema 23 closed-loop stepper motors. It would be better to use dual limit switches to make sure they won't be out of sync. 2. The machine frame is fairly rigid considering it's using thicker aluminum extrusions, and it also works well with the 400-watt spindle. The spindle is controlled by a knob to regulate the current of the power supply to control its speed, so it can't be controlled using Gcode. Considering that the closed-loop stepper motors and the ball screws are so good, matching them with just an aluminum frame and double-sized palm wheels on the X and Y axis may not be the best combination. So, Genmitsu could consider creating an even higher-end model featuring a steel structure and linear rails. 3. The MDF and T-slot hybrid bed is nice, but I would prefer some screw threads on the MDF for better mounting. For milling aluminum, using a small vise would be much better. I can still fix the vise using the set of clamps they provided, but having more threads on the MDF bed would be better, so you can mount a vise to hold an even larger piece of stock without worrying about the tool hitting the clamps. 4. The engraving bits and end mills that come with the machine are relatively basic. It would be better to include some single flute or double flute end mills, enabling users to work with aluminum right out of the box. In conclusion, this is a very solid hobbyist desktop CNC. It can work with softwood, hardwood, acrylic, and aluminum with pretty good results. This machine is more than sufficient for the occasional production of metal parts at an acceptable speed and with presentable quality. It's unlikely that you'll find another machine within this price range that offers both ball screws and closed-loop Nema 23 stepper motors. If you're looking for a better desktop CNC than a flimsy 3018 and want a larger working area, you can definitely consider the Genmitsu 4030 PROVerXL V2. I put the link under the description. That's all I wanted to share about this machine. If you found this video helpful, please consider giving it a like and subscribing to our channel. Thank you for watching, and I will see you next time.